I start the session by welcoming you all. Very good evening, and I would like to first congratulate all of you, all of us, for such a historic moment that we witnessed on 23rd August. That is India's uh, first mark on the lunar surface and being the first country to touch the lunar south pole. So it is a very big achievement, not only for the ISRO scientists, but all of us who are directly, indirectly connected, or who understand the science behind these kind of programs. So on this note, I would say that we are towards the end of this week, and with this, we are also having this as our last session in career guidance talk. And from next week, we will be starting with the orientation program. If still some people, few students may have doubts, so we will try to clear their doubts by today in our sessions. So first session will be led by Dr. Selva Kumaran, who will be speaking about Hunt for Life Beyond Earth and its current status, basically. And towards the end of the talk, we will have Dr. Pavitra, who is our course coordinator for MSc in Astrobiology and Space Sciences. So she'll be talking about the program, and also any doubts if you have regarding this course. So with this note, I would first like to invite Dr. Renita, our head in charge for Center of Excellence in Astrobiology, to have a welcome address and the introduction.
Thank you,
Please,
Sneha. Yeah. So it's a pleasure to extend a warm welcome to Dr. Selva Kumaran and Dr. Pavitra, assistant professors of the Center of Excellence in Astrobiology. And I also welcome all the participants who have joined in today's session. So as you are aware that it's a new program that we have launched, first of its kind in India itself, MSc in Astrobiology and Space Sciences. So pertaining to this, there were a lot of queries related to what the course is going to have, what are the future prospects, what is it that we are going to learn from it. So as Neha said, we had a set of a series of sessions based on the expertise of the different faculties who are there, as well as we had guest faculties. So this is the fifth session and the last session. And this session is going to be taken by our own teaching faculty who will be there in the MSc Astrobiology course, Dr. Selva and Dr. Pavitra. Both of them have done their UG and PG in physics. Dr. Selva has a specialization in space science, and Dr. Pavitra has a specialization in planetary geophysics. So in our center, since astrobiology in itself is a very interdisciplinary field, our center also has faculties from an interdisciplinary area, beginning from biology, physics, astrophysics, engineering, geophysics. So today's first talk by Dr. Selva, A Hunt for Life Beyond Earth, what is the current status, is going to have aspects related to what are the various missions that are being carried out for the search of life all throughout the solar system as well as in the exoplanets. And the second talk is going to be by Dr. Pavitra. She will talk about how her journey began from being a physics postgraduate towards entering into the field of astrobiology. Apart from that, she will also give you the details of the course that we are going to have. What are the things that you will be learning? What are the key aspects that being in Amity you will be able to gain in? So today's session is going to be helpful for all our students, prospective students who plan to enroll for the course, as well as the students who have already enrolled for the course. And I'm sure it's going to be a very enriching experience. And I encourage all of you all to actively participate by asking whatever questions and doubts you all have. So thank you once again for your presence. Hello.
Hello. Yes. Thank you, Dr. Renita. And I think without further delay, we shall start with today's first talk. So I invite Dr. Selva Kumaran to start with his talk. Please, sir.
Yes, thank you. Thank you for giving me this opportunity to give this talk. So this is how I arrange my talk with the title. You can easily understand like Fund for Life Beyond Death, current status.
Dr. Silva, sorry to
Yes.
interrupt you, but can you please put this in slideshow mode, your PPT?
I put in slideshow.
We are not able to see where. Yeah.
Is this okay now?
Yes, now it's fine. Thank you.
Yeah. Okay. I'll just continue where I left, like Hunt for Life Beyond Death. Basically, the things which we know is like we have life at Earth and we are human beings and we know the surroundings and life existing here. So what are the possibilities? Like we have to see if in future cases, like we go to the other continent in a world now in the Earth, like whether there is any possibility, like if hazards comes to our Earth, like any possibilities, like we can go to other planets or other system like solar system, other stars which has planets which are habitable. So it's something like it's an outstanding research and it's going on for a long time. And people and researchers, basically these researchers trying to find like, is there any possibility of life apart from Earth? So we can switch over there. So there can be so many questions. So before we start, like we will be having this set of questions, like exploring the life is like exploring life in other places. It's kind of solving a really big puzzle. So when you see it's a big puzzle, sometimes you will have the answer, sometimes you don't have the answer. Like current situation on exploring a life beyond Earth is like not answered completely. But the thing is like something are answerable or we are close to them. That's what I'm going to tell you about today. There are three main questions need to be addressed when you look for life outside here. The three things which will come to your mind, like the things which you need to answer when you in the course, so that we can understand there is a life apart from here. The three main questions are: where do we come from? So we should know our origin. Like as we know, we are human beings and we are originated from our source. So we should understand ourselves. How does life begin and how does our life begin and evolve? So first, when you want to study something out of your hands, so just you should understand ourselves, and you can compare the things with us to the other things. So in that way, you can go ahead and get the idea of the other beings, human beings, or any other living organism in other planets. So first, we need to study ourselves, and the next question should come is like, are we alone? Like are we alone in the universe to have something life like this? If there is someone apart from us is having the similar like us, similar organisms or any other way of life, so how can you detect it? So it is something you cannot address by saying like there is a life in that particular planet, a particular particular galaxy. So some way you have to detect and confirm is the possibility of having them. And also like like you know about you and you're trying to see whether there is a life apart from Earth and there is existence, and you know how to detect them. So in that case, you should be able to think in the next stage, like if there is what is the future of this Earth, and if the Earth is going to disappear in some particular day, is there any escape there we can go to the other place and survive, and we can continue our generations? So these are the three main questions need to be answered. So the answers for these questions comes from this slide. So you can see the basic slide. You can see from the basic slide. This answer for these questions come answered through a subject called astrobiology. So basically, this astrobiology covers everything, basically everything in the sense existence of life, the physics behind the life, the chemistry behind the existence of life, origin, evolution, distribution, and future. So it's all about the life. It's not about the human being along only on the earth. It's about someone who is outside of the earth. So it's a study of some human or living organism which can be present apart from the earth. So it has multidisciplinary, and it is a multidisciplinary. So the astrobiology has branches everywhere. So when you talk about astronomy, it is linked. When you talk about chemistry, it is linked. When you talk about biology, it is linked. When you talk about physics. So the answer for the question which I posed in the previous slide is answered by the subject called astrobiology. This subject will give us idea. Basically, the subject in the sense the research in this field, the subject is research in the field, and people work on this and will be able to get the answers which I posted in the previous slide. Where did it start from? So when I talk about life beyond Earth, where did it start from? In the 19th century, there was one astronomer. So you can call it as astronomer. That time there is no concept of astronomer. Something like whoever has a telescope, they look on the sky and they look on planets through the telescope. After the invention of telescope by Galileo, many people had the opportunity to use the telescopes. So they look on the sky and they look on the surroundings apart from Earth. And the person named Giovanni is an Italian, and he has told like there are canals. So there are like mark of canals, the flow of water. You can see here the canals now in Earth. So similarly, he has told like there are series of canals in the Mars. So through the telescope, he told like there are canals with the mark of water is there. He was the first person to come across something like this, and he has notified this, and he has given talk on this, and he has published everywhere about this work and showing some canals in the Mars. So basically what he wants to tell is there's a possibility of water in the Mars, or something there is life, and which we don't know. Through the telescope he could see only the mark of the canal which was present. So it was in the late 19th century. He was the first person to see beyond. So people are seeing the with the telescope after invention of Galileo and the telescope, they are looking at sun or the other planets in exploring the things, not in the way there is possibility of life. He was the first one to venture something. There is something in life. He was putting something in terms of life. So this was disproved in 1969 after Mars mission from USA. They have disproved by the closer image through the satellites. With the images they have taken closer to the Mars, they have disproved this theory, like having a mark of canal. It was something different. It was something kind of crater types, which he misunderstood and mistold. But still, even he has misunderstood and mistold, he left the way. So he has started a way of seeing planets in other way around, not as a planet. It's the possibility of existence of life. So he was kind of pioneer in theme, even though he's wrong, but somehow he paved a way for that. So what are the different search types? So we have different search types. Search in the sense that it kind of, when you know there is a life at other place, so you need to search for it and you need to have evidence for this. So if there is any life present there, and what may be the properties of the life there, how do they exist? So first, initially, we know about our solar system and many of the planets we know. So 8 planets we have in the solar system, so we know everything. And there is a possibility like other planets. So outside our planets, we may have like our solar system, there may be some other system where we have a sun as a center with different planets surrounding them. So we need to first thing is like we will look into our solar system in the planets where we can have life, different possibility of life, different ways it can appear or it can sustain. So in the similar way, so there is something called extrasolar in the sense like the planets, the study about the planets outside our solar system. So what are the possible way you can study using telescope? from the ground, we can have a telescope. Now even you have a space telescope. Before now we have two space telescope for study of this, like Hubble Space Telescope, which was the previous one still in there, and now the recent one is James Webb Space Telescope. So we have two space telescope. Basically, these are used to be like when you study about something about other planets outside of solar system, the more possible you have an optical telescope. So optical telescope in the sense you are really seeing through the eyes of the telescope, you are really seeing what is happening there, what were the constituents there. So main thing is like having different spectroscopy study, those are fine. So apart from that, it's more better you have optical study also. So optical study in the sense is just like telescope, like you see from your eye through the telescope, you're seeing what is there in the different planets. So telescope within the, so we're using the telescope, you can see within the galaxy. So, and also there are like other solar systems you want to see, you can see the information of atmosphere. Apart from optical, you have a different spectroscopic measurement. So you see, so when you see these different characteristics, like what is there, what is the atmosphere is there, or whether the oxygen is there, the habitable. So if you identify the planets having all these situations, and when you know, so you there is something existing, like information about Mars. You have every information about the planet. Then you come up with the thing like, is it possible to have a life there? So this is where you have to go one by one. First, you start with identification of the planet and the measurement types, and you see what are the possible things are present in the planet, and finally you enter with whether it's habitable or not. So this is about the extra solar system. So apart from that, we have in our solar system, we have different planets. The so closest planet we have close to Earth is like Mars. In the side, Mars and Venus are very close, and it is closer orbit to the Earth. Mercury is very close to the sun. It can experience very high temperatures, so the possibility of life is not possible. After Mercury, the Venus is there. Venus is also close to sun, though it is similar of Earth, but it has a high temperature, radiation exposure, so it's possibility. So after Earth, we have a mass of similar features. So many people, many times they look on Mars. So many people, many scientists today look on Mars. So what are the possible things which we can explore Mars? So there are like missions, like missions in the sense. So exoplanets, before I was telling exoplanets are apart from solar system, you have a different planets. It's very impossible. Like with the current technology, it's impossible to send the satellite to there or mission to there to reach there and put your lander or rover. So recently you have a moon lander. So similarly, like exoplanets, like planets in solar system is at least achievable. You can reach there and you can study those things and you can send to missions. So that's what I told. First, you start from the Earth and you go to the solar system and planets, then you go to the exoplanets. So this is the way you order it. The study of the orders should be. So mission visits in the sense like you can send Mars missions. So there are so many Mars missions from USA and ESA. Basically from US and ESA stands for European Space Agency. So they send many missions to Mars to identify like what are the possibility, how the atmosphere looks like, how the surface looks like, what is there beneath the surface. So there's with the heat of meteorites on the Mars, they collect samples and see fossil evidence like whether it is not about the present, it is also about the past. So past, what was there in the past, what was the human being, if there any life existed in previous like long back and they disappear, like you have dinosaur which existed in Earth, they disappear. So after some meteor collision, so if there are any symptoms, like you have any fossil evidence of of life before, not now. So these things have to be done. So our solar system, so biological and potential habitability. So since it's close to Earth, we know. So other places also there may be similar conditions, but we don't know. So it is far from our reach. We have only optical observation or some spectrography observation, which we cannot tell exactly. There may be, but you will never know. So can we find the evidence of it now? So every time we need to see the target and see what is the condition there, and next we'll move to, is it possible to have life? So the closer one which I told is like mostly explored planet in our solar system is Mars. Apart from the satellite, so moon is the satellite which is more explored. So since it was a satellite, I'm not considering here. So only planets I'm focusing on. So I'm talking about planets. So Mars is the one which is focused here. So they study for rocks, evidence of some biomarkers, search for liquid waters and other clues like environment, the atmosphere. So they keep on exploring Mars. So if on Mars, if there is something in Mars, then we can go for other planets and other exoplanets. So these are the different missions. So basically, it started in 1976. So, yeah, in 1976, the US sent like Viking Mars rover. So they have sent on the place Mars at particular location, and they tried to collect samples and analyze in 1996, 2003 on different names, 2007 and 11. The recent one is Mars 2020. You might be knowing that in Ingenuity helicopter it took off in the Mars. There are so many space missions on Mars. These are mostly contributed by USA and ESA. So the basic study here, they try to explore the presence of water. So every time they explore more, they could find more indication of water in small and large scales. So this gave an idea. They gave idea. This about the Mars. They could explore more, but currently in the Mars, life is not possible. Life is not possible means it's for the human beings to sustain there. It's not possible currently with the conditions there, with the presence of water. There are presence of vapor there, with the presence of oxygen level. The human cannot exist without any without any support, life support, like oxygen support. It's not possible to exist. That's what they could make up. But still, the research is going on to see if there is any past life or any possibility of changes, if there is any meteor hitting or anything that changes is there. So it is possible to have in future. So if it is possible to have in future. So there are small scale evidence for the past waters, like you can see some Mars explosion, that's the sedimentary layer, former salt, watery past. So these were got from the different missions. So I'm not mentioning each missions what was that. I'm just giving the overview of all the missions from the Mars, what they got. So basically. So apart from Mars, the thing which was explored more is the Jupiter moons. So basically, why the Jupiter moons came here is something like when they had this Galileo mission. So the Galileo mission is something like which was sent for the Jupiter, and Jupiter they during that time the mission Galileo mission has discovered 4 natural satellite of Jupiter. So in that 4 satellite, there was a lot of studies, because whenever there is an after that Galileo mission, they have discovered these 4 satellites associated with Jupiter. And the next mission, there was something called the JUICE. In the mission, they could able to find out like something like icy bodies on the surface of these satellites. So icy body in the sense it's like minus 100 degrees, less than very cold. Yeah, as Jupiter is far away from the sun, you can expect it to be a colder surface. The interesting thing is like the scientists after their many missions, they could understand like though it is the surface of these satellites are icy. So when you go deep into the surface, like when it goes inside in the layers, the temperature increases. Basically in Earth also, whenever you find there is a temperature increase when you go inside, close to the core. So when there is a temperature increases towards when you go to the core of this satellite, there is a possibility of water flow. Though it is cold in the surface and it's icy object, so the scientists were expecting there is a possibility of having water beneath the surface. So this was by different missions. There is upcoming mission from NASA, which is called Europa mission, based on this Europa's satellite which was found in Jupiter. So what they're planning to is they're planning to send only to the satellite, not for the Jupiter. Before these missions or everything went for Jupiter. In their in their rotation over the Jupiter, they could be able to find the satellites and some of the features of the satellites. So they in 2024, they're planning to send only for Europa. The mission is planning to launch by 2024. So the mission that Europe, after different circle over Earth and different planets, finally it will reach Jupiter in 2030. So that's what I told you. Like exploring our solar system is like it's a huge task. Like when you launch the satellite at 2024, you will be able to reach the satellite of Jupiter after 6 years. So this is the time it takes, it consumes you to reach some other planet. So when you talk about exoplanets, it's, with the current technology, it's like practically impossible with a particular generation of study. So with a particular generation, in the sense like the researchers are now, they plan for a mission, they cannot execute in their lifespan. So it has to go for the different next generation to get closer to other planets which are out of our solar system. So searching for life. As I told you, like search for life. Now we are, when you know something about our solar system, and we could now close to say there is no existence of life currently. There can be in the past, and there could be in the past, and there can be in the future. So which we don't know, in which are meteoric impacts or some other changes in the atmosphere, some other changes with the composition. So possibly trigger up the future upcomings. But when you talk about exoplanets, basically, as I told you, the puzzle, this is going to be very huge task. So when you talk about our solar system itself, like as I told you, for the reaching Jupiter, it takes 6 years. When you talk about the exoplanet, the real problem is happens how to reach there. And also, even though you reach there, there are lots of stars that are in between. So you have, when you see, like you have a star like sun, and you have other planets close to that, the star brightness is too much. So when you want to study about the planets closer to Earth, yes, closer to sun, it's a very difficult because the star brightness is too much. The sun brightness is too much. It can engulf Mercury. The similar way, when you go away from the solar system, so the even that with the distance, the distance between the particular star and the associated planets is going to be very closer. So from the view of Earth, from when you view from Earth or space, it is going to look closer. It may not be closer, but it look closer. The brightness of the other star, which is the planets are associated, can engulf, and it won't let us to explore more. So that was the practical and very practical difficulty which people face when you go for the exoplanets. So there are different observations. So there is one called infrared observations to see the exoplanets. So basically they work on radiations. So they work on radiation in the sense they send signals and they explore. They try to explore. There are huge. This has optical as well as the observation from spectrometry. So optical in the sense that's what the practical disability problem is like. When even though you have an optical, so it is dominated by stars of other planets, other exoplanets, where the star is associated. We have to overcome those star brightness and see the planets associated with them. It's a simple philosophy, like someone is coming with high beam when you go by a car. Someone is coming opposite. There is a small vehicle coming close to that, the high beam from the opposite car. So you can see the person who is coming by a cycle in the nearby, the beam which engulfs the surrounding. The similar way. So when you have a star with a high brightness, it can basically you can't see the other planets around. So apart from that, I told you there is a Hubble Space Telescope in the space. This is about the ground. This is about the space telescope. So this Hubble Space Telescope also can continuously. This is in the space, and it doesn't have any influence from the Earth, but it has influence from other galaxies, other stars. Still, it's in a better position, so you don't have it doesn't depend on sunlight, and it has no influence of sunlight because it's in the space. And also it is the next that recent one is James Webb Telescope is backside of Earth. So backside of the Earth, it doesn't have a sun affecting to that telescope. It keep on viewing other galaxies outside our solar system. So outside our solar system, it keep on seeing other other exoplanet possibility, galaxies, the formation of stars, those things they look upon. So these are two direct methods like optical and space missions. There are also some indirect methods, detection methods of finding out exoplanets, appearance of planets, where the first now we have to look at planets, then we have to look if there the possibility of life existence. So there is a thing called radial velocity movement and Doppler-Obel method. There are different methods. So I'm not going much into details. It's entirely a new thing to explore. That's the whole the radial velocity concept itself takes one lecture, and the Doppler method itself takes one more lecture to explain the method how they trace it out. So as I told you before, when the evidence of life is something we could detect evidence of life by observing spectra. That's I told spectroscopy is the easy way to observe our planet atmosphere. So this is something like you have, this is the spectroscopy. Spectroscopy in the sense something you get from the radiation, it get observed or it get emitted by two different ways. It can get observed by the molecules present in between you and the observing point. So either it can be observed or it can be emitted. So based on that, they can identify the chemical composition present there. So this is the normal spectroscopy spectrogram is called spectra, which we get from the air. So you can find the ozone is there, water is there, the carbon dioxide, and different region you have a different spectra. So when you compare this with Venus and Mars, so here you can see with a temperature, brightness temperature, and you can hear with a different wavelength. So different wavelength in the sense the spectra observed with a different wavelength. Here you can see the presence of water O3, which is carbon dioxide is there, but you don't see in Mars water and ozone. So basically, this ozone protects us from radiations from getting us affected. So this is missing. The major constituent which is missing in Mars and Venus is this water and ozone. So still the exploration will give you, so it is not something like 100% there is no water. There are traces of water which was present before, but still researchers are trying to identify if there is any possibility in the future. So this is all about how the possibility of planets and where the exoplanets or whether life can exist or something like that. So there is another set of people who think there is a life. And there is a life in the sense there are some others. Like as human beings, there are aliens. You know about the aliens in many of the movies you might have seen. We call it them as aliens. For them, we may be aliens. So the person in the earth, for them, may be aliens. So people think there are like life and there are aliens in different galaxies, different planets outside our Milky Way. So there is a possibility something like this project basically is proposed by Cocconi and Morrison. They published a paper that you should to have a big radio telescope and sending radio waves continuously to communicate across interstellar distances, so different stars out of our galaxy, Milky Way, and to different people. So what they expect is something like radio signal they send throughout the universe, and they feel like some other stellar place where we have a better aliens, like better technology person than us, can receive the signals and send them back in a different frequency or different input. So what this project will keep on sending signals, keep on sending signals throughout the stellar, and they try to see if anything is coming back. If they get back something, they can understand that there is a possibility of life, and there are some aliens there. They are sending back the signals. Where to look? So instead of you can't send it blindly. Many search they target like sun-like stars. So sun-like stars in the sense like they think like the researchers think like the stars, which is like the sun, as a planet, can have a planet like Earth which can support life. So there was a project OSMA which was conducted by Frank Dirk and Greenberg. This was the first project. That was the paper. That was the idea. They executed in 1960. Very first SETI observation in what called Project OSMA. The thing they could find is that by the continuous sending of signals and everything, and they could able to find out only this spy plane apart from that. So they could not find any like aliens or which can send signals back. I'm coming to the last step basically, like number of stars born per year. Milky Way is something, the estimate is 7 stars per year in our Milky Way. I'm talking only about Milky Way, the other planet. In our Milky Way, there are 7 stars per year. So out of which 73 to 84 stars in the Milky Way are M type. These are too cool when compared to Sun. The upper limit of this 21% of stars in the Milky Way are like our Sun. So when you narrow down from the 7 stars, we could be able to have 1 star. In every 7 star, we could be able to have 1 star which is similar to Sun. So the researcher expert, out of 1 star in every year, with hundreds of years, there is possibility of 1 star like Sun possible, and the planets surrounding us like Earth is also possible. So as the time goes, we will able to detect many more. So a fraction of sun types are with planets. So these are like theories which they tell there is a possibility, but we don't know what is exactly happening. There may be 10 to 30% of stars with planetary system. So that is also there. So it should be like terrestrial planet also, terrestrial in the sense which should support life. Again, we don't know. We are finding many solar systems where we don't believe there can be Earth-like planets. And also there is something called, based on our Earth, there is something called habitable zone that here blue mark. You can see there is habitable zone in the sense everything based on human observation, like how we like, how we are living in the Earth based on our habitable zone, that zone is formed. So it may not be same for the different galaxies, other than apart from our Milky Way, there can be life in other other places, other stars, planets have a different habitable zone. So this is a habitable zone which is possible for a human being to survive. The aliens can survive with a different habitable zone. So this is just the reference which was made by the Earth. So fraction in others. So finally, I come to the slide. What needs, we believe, a very long time to allow life to evolve. So when there is a life, we should have a longer observation, and they also take longer time to evolve. So really difficult to estimate how often a planet will have a temperature climate for long enough. So like Earth, you should have a like stipulated temperature in the sense that there should not be extreme change in temperature. Like now also you could see like in Chandrayaan, the lander and rover, they have a 14, that rover has a 14 days lifetime because it lands in the day. 14 lunar days is equal to 1 day. Our Indian Earth, let's say, our Earth 14 days equal to 1 day for in the moon. So during the 14 days, it gets charged, it works on. During it goes to the night, there is a temperature difference of 300 degrees Celsius. So it is close to 300 degrees Celsius. So it is very difficult to survive. So I end up with this, our human race is very special. So and we need to find a different, more techniques, more technology development to have life on, to see whether the life exists in other places. So by this, I end my talk. I ask Neha to take over.
Yes, thank you, Dr. Salva. I think we should start with our next talk immediately. Meanwhile, I also request our participants, if they have any questions, you can post it in the chat box, and I'll request Dr. R. Selvakumaran to look at it. And if you can just figure out the questions, and we will take up the questions at the end of the second talk. So I now welcome Dr. Pavitra to talk about the course and her experience. Please.
All right. Thank you, Dr. Sneha. Can you hear me? Am I audible?
Yes, you are.
Okay. All right. Thank you. So good evening, everyone. I am Dr. Pavitra Shekhar. I'm an assistant professor at the Amity Center of Excellence in Astrobiology. So what I will be doing today is I will give a gist about my journey to astrobiology and also give some insights into the actual first time ever master's course in astrobiology and space sciences. So let me just share my screen. Just give me a minute. All right, is my screen visible?
Yes.
Okay, all right, thank
Please.
you.
Yeah.
Yes. Okay. So as you can see, one of the things that I'm going to be talking about and focusing a lot more is this upcoming first ever master's course in astrobiology and space sciences. But before that, I would just like to give some insight into my background. So I began as a physicist. I did my bachelor's and my master's in physics. So you can see some of the research projects that I've put up here, which have actually led me to astrobiology. So the first image that you see on the left side is actually an astrophysics project that I worked on. So if anyone's heard of blazars and Seyferts, what I was trying to do was analyze the frequency that was coming out of these blazars and Seyferts and trying to see if there was a correlation that I could find with a lot of these objects, which we believe are billions of miles away from us. And my fascination for planetary sciences began with space, like most people. So this was the first option that I had, was to actually work with Birla Planetarium. And that was one of the most interesting projects that I had done during my master's. After my master's, you can see the image on the right-hand side, which is actually the topographic figure of the surface of Mars. So if anybody is aware about Mars, Mars is very unique, especially if you can see from that image, you can see the elevation differences from the southern and the northern hemisphere. So during my PhD, I was very fortunate enough to work on a NASA-based project where I was trying to understand the volcanoes on the surface of Mars. How did they come about? When were they actually placed? Why is the surface of Mars or the topography of Mars so unique compared to our own planet and any of the other planets that we see out there? So if you can see here, what I actually did was took the data that we had at that point, and then I did 3D modeling and simulations to understand what was happening inside the mantle. So what was actually happening inside the planet and how they actually make it to the surface, and can this melt actually create the volcanoes on the surface? So there were obviously a lot of constraints during that time. For example, you have to consider the timing of the volcanoes, whether it was really early on, like 3.5 billion years ago. Are there any current isolated volcanoes on the surface? What kind of valleys, gullies do you see? What kind of crater system does it have? So if you see this image, which is the third image on the side, is the actual 3D modeling that I got to work on during my PhD days, where I was actually given a lot of insight into geology and geophysics at that point. So my major shifted from physics to geology and geophysics and became more of a planetary geophysics. So I had to definitely understand a lot about the geology, the rock structure, the minerals, what you see on the surface. And here you can actually see the red that you see on the surface of the plume head, as what we call it, is actually the melt that was formed through these 3D modeling and simulations. So what happened during my PhD days is this fascinating work on Mars led me to my postdoctoral work, which is the fourth image that you see down here, which is actually a black smoker image. So if anyone had attended Dr. Sudha's talk, she had talked about hydrothermal vent systems. She had also talked about how we have these black smokers and why they're very fascinating. So this is actually a mid-ocean ridge, a mid-Atlantic ridge, where you can actually see activity coming, so the tectonic plate activity. And here as well, if you see the last image on the side, we can actually see the simulations that I was trying to do was to understand if you can have a certain type of activity, certain type of volcanic activity that actually happened under the crust, how does it make it to the surface, and what do you actually see on the surface? Now, everybody might wonder why from a physics to a geophysics to a geology, and then how astrobiology. So a very interesting concept here is this kind of hydrothermal work or even hot spring work actually does have implications to astrobiology. For example, the organisms that you can see or the organisms that can survive in these extreme temperatures, whether extreme salinity, extreme temperatures, extreme pressures, can organisms live in these environments, and what would be some of the conditions required for it? So the entire reason I'm sharing this slide with everybody here and potential students is to show you that you can come from different backgrounds and you can come from different fields of sciences, engineering, and actually contribute to astrobiology, because there are always multiple options available out there depending on your field of study. So this slide here tells you where my specialization is. So starting from physics to geology, geophysics. I was also capable of actually and fortunate to actually teach courses in meteorology, a little bit on planetary missions, and also earth and environmental sciences, because everything constitutes as astrobiology depending on which perspective you look at it from. So these are some of my skill sets. In addition, the other members from the Amity Center of Excellence in Astrobiology, we also have interdisciplinary faculties, such as the talk that you just heard by Dr. Selva and the host, Dr. Sneha, who have backgrounds in space physics and are also planetary scientists. We also have Dr. Renita, Dr. Vinod Kannan, Dr. Shushan, who also bring the biotechnology perspective. So we have specialization in microbiology, biochemistry, and so on. So from this, you can see that this is definitely a very strong interdisciplinary field, depending on where you come from, and how you choose to specialize is dependent on your interest and also the faculty projects that are available. Now, using this as a background, I'm going to jump into the actual master's course in astrobiology and space sciences and give you a gist of what is actually there in the course and what we offer. So this website is actually, this is a screenshot of the website that's actually available there online. So you will be able to access this course if you like. This is a 2-year master's course. The eligibility, as most people might know, is having your bachelor's, your undergraduate degree in sciences and engineering. We are pretty open to a lot of the sciences and the main fields that are actually involved in astrobiology. This obviously is a course that we are doing at Amity University, Maharashtra or Mumbai. And we actually have 4 semesters that are a part of this course. So I'll give you a quick gist of what is actually involved. So we begin with the assumption that we're getting a lot of students from different backgrounds. So the first semester and the second semester focuses on a lot of introductory courses. So if you see here, we pretty much have introduction to geosciences, which will talk about the minerals, the rock structures, and geomorphology. We also have introduction to space sciences and planetary sciences, as you saw, the talk that was given prior to this. So we'll be talking about the star, our solar system, also about search for extraterrestrial life, and so on. We also have introduction to biochemistry. So here we talk about the lipid structure, cell structure, membrane structure, and so on. We have analytical techniques, which talks about the instrumentation part. So centrifugation, how the instrumentation works, what kind of instruments would be crucial for doing analysis. Other than that, we also offer practical courses. One course goes with geosciences, and the second course goes with biochemistry. So here you get to actually work in a lab using the knowledge that you gained in the lecture sessions, and you get to apply that in a practical course. So you get to actually have some hands-on experience. Now, before I go to the second semester, I would also like to inform that there are also options for languages. So you will have exposure to French, German, Spanish, the language of your choice. There are also certain other self-development skills that you will learn, which is a part of the actual master's course at Amity University, Mumbai. The second semester will switch gears a little bit, and you will get a little bit more insight into microbiology. So where we talk about the characterizations, the structure, what kind of organisms are we looking for. We also have geosciences 2, which will talk about more about resources geology. As you know, resources are very important, no matter what planet you're looking at, whether you want to do travel, whether you want to explore the planet. So we look at resources. We also look at geochemistry, geobiology. Statistics for biologists is a course where we talk about statistics as the name states. So we talk about mean, probability, how do you deal with the data correlation that you actually collect. Then we've got Introduction to Planetary Environmental Sciences. So there we talk about the basics of global climate change. We talk about why the environment is important, the food chain, the food web. But we also tie that into the planets. So in respective planets, how is that important? What is important about the planetary environment in each individual planet? Then we move on to planetary meteorology. Here we talk about tornadoes, hurricanes, and all the fun stuff, which a lot of students are actually usually very interested in. But again, we also talk about the atmosphere. So a lot of the larger planets like Jupiter and so on, it's very important for us to understand how the atmosphere works. So the vertical structure of the atmosphere, can you correlate astrobiology to different planetary atmospheres and its importance? In addition, you can see we've got 2 practical courses. The first one is microbiology, geosciences. The second one is the planetary environmental sciences and meteorology. Now, with respect, so these are the core subjects that we'll be offering. Also, we give the students the opportunity to work on something called a term paper, which depending on the student's interest and the faculty's interest is usually decided on what kind of term paper they want to work on. So it is more like a review article, which usually gets published in due course. So you spend all your time trying to do the review work for a topic of your interest in astrobiology, and you work with the associated faculty for it. We also have a research article presentation, which is more like a journal club. So you get to get an insight as to how to publish a research article in a successful manner and what are the steps that are needed for you to publish it successfully. The third semester is where we look at space biology. So here we actually have certain specifics like space physiology. So what are the effects of microgravity? What are the effects of light on plant? What kind of, if you were related to certain types of future missions, what are the things that would be required? So in space, what are the effects that would happen with the biological aspects of it? We've also got astrobiology missions where we talk about the goals, how a mission is successful, how do you design a goal, what are the important steps that are required, including data collection, maybe grants, funding, and so on. So how do missions work? Then we have a research methodology, an IPR, which is intellectual property rights, biosafety subject as well. So that gives you an insight into how to work with patents, how do patents work, copyrights, trademarks, and so on. We also have 2 practical courses, as you can see there. So space biology, where you look at the effects of light, temperature, pressure, and so on organisms. And you've got astrobiology missions as well, which focuses on how to write a mission and what are the goals involved in it. In addition, in the 3rd semester, we've got some very interesting electives, which is totally dependent on the student's interest. First one is astrobiology missions, which would be a continuation of astrobiology mission 1, where we talk about planetary protection. We also have extremophile and deep sea microbiology. So this is where we talk about the actual extremophiles that are actually involved in extreme temperatures and so on. So hydrothermal vents, what kind of extremophiles do you see over there? What are the characterizations? Then we've got basics of plant and animal tissue culture, where we also look at plants and the tissue culture and what is actually important and how it ties into astrobiology. If you notice here, we also have the term paper 2, which can be a continuation, or depending on the project, it can vary. And we also have a summer internship, which is usually a short duration that you actually get to work with a scientist, where you can improve your research skills and hone in more on what you're actually interested in. The last semester is actually your project and your dissertation. So by this time, students would get a good insight of where their expertise lies. As I mentioned earlier, the Amity Center of Excellence in Astrobiology has faculties from multiple various disciplinaries of sciences and engineering. So depending on that, dissertations and projects, we will be proposing in-house projects which students will be able to take in and work on that. And obviously, if they're interested to continue with research, proceed with that for the future. There are also certain research organizations where they will be able to, do some work, some kind of research as well in collaboration with us, or depending on the interest, actually have that opportunity as well. So that would be their final dissertation and project. So with this, we'd like to open the session up for questions, either in what Dr. Selva had talked about, or if there are any questions for the master's course, we'll be more than happy to share any answers that we can share with you. Thank you.
Thank you, Dr. Pavitra. I would like to now know if the students who have joined, they have any questions to ask or any clarifications that they would want from us. Any questions? If you have any problem with your mic, you can also post your questions in the chat box. Any questions? I don't see. Yes. So if not now, if you have any queries, you can also mail to us. You can reach out to us, and you can ask anything regarding the course, or if you have any questions. As Dr. Renita has posted, you can just copy this mail ID and you can post your queries there.
Yes, we have a comment from Ilan Gurali, who was a part of the EACP Ladakh sessions as well. So just thank you for participating in this.
So with this, I would ask Dr. Renita to just present vote of thanks. Okay, so one question before we move further. Preetham Kumar Das wants to know when the class is going to start.
Yes, so the classes officially start on Monday. So Monday is the first day of the session. So not very far off.
Yes. And I don't see any other question. So I request Dr. Renita to take over.
Thank you, Sneha. So on behalf of the Center of Excellence in Astrobiology, I would like to thank Dr. Selva Kumaran and Dr. Pavitra for their wonderful talk. So as a biologist, it's a pleasure to listen to the various aspects of exploring life using various instruments. It gives us more knowledge onto what all aspects can be covered and can be added also. And I also thank Dr. Pavitra for her talk on her journey through physics to astrobiology, and also giving our students a glimpse of everything that would be covered in their first semester, second semester, as well as their third semester and their final year, and the additional benefits and courses that they would learn during the during their master's course. I also thank all the participants who have joined us here today. Thank you very much. And we also thank our Vice Chancellor, Sir, Professor Dr. A.W. Santosh Kumar, and our HOI, Sir, Dr. Penna Suprasanna, for their permissions and their guidance and support. And lastly, I also thank the IT team, the media team, for all their arrangements. Thank you. Okay, there is just one continuation to the question I have applied yesterday, when the admission process will start. Okay, so Preetham, you mean to say you have applied for the course yesterday? If that is what I understand, if you have applied for the course, once you have applied for the course, you will have a round of interview. So after your application will be processed through our admission team. You will have an interview maybe within 3-4 days time, and post the interview after your if you have cleared the interview successfully, then within 1 week you will get your admission letter. So I have already posted my email ID over there. I'll post it once again. So in case you have any queries related to the process of admissions, or you face any difficulties during the process, or if you're not getting any call related to admissions, you can mail me on this email ID. Okay. So as Dr. Pavitra said, we will be starting with our course next week. Monday is the first day wherein we'll be having our orientation. Post that, we'll be beginning with our lectures, but our admissions are there for a few more weeks. We are open for admissions for a few more weeks. Okay.
Okay, thank you, Dr. Renita. So I would like to now declare that the session, today's session is over and we can leave. Thank you once again, all of you, for joining. Thank you.
Thank you.